In this presentation, I'm going to discuss the allowable strength design of a reinforced concrete two-way slab based on eStructural Design Taichi found on the App Store. The required input parameters for a two-way slab design are as follows. Name of slab like S1, S2, case number, longer span, shorter span, slab thickness, size and grade of short and long direction bars, the strength of concrete used, and design loads that includes dead loads and live load. Given the FC prime and Fs, get the balance section properties of the reinforced concrete design like N, the modular ratio of elasticity, K, the height of the neutral axis expressed as fraction of the effective depth, J, the length of internal moment arm expressed as fraction of the effective depth, and R, the factor for resisting moment in concrete. Take a 1-foot strip of the total uniform load by summing up the following. Self-weight of slab equals to assumed thickness times 12.5, live load from minimum occupancy load guide, floor finish and partition if any. Determine the design case number of a two-way slab based on panel edges like Case 1, all edges continuous. Case 2, 3 continuous edges and 1 discontinuous edge. Case 3, 2 continuous edges and 2 discontinuous edges. Case 4, 1 continuous edge and 3 discontinuous edges. And Case 5, all edges discontinuous. Refer to this table for the moment coefficient of two-way slab design based on case number and the ratio of shorter to longer span. Interpolation may be needed in some cases. Based on the input parameters, balance section properties, the total uniform load, and the case number, solve the following. Negative and positive moment of shorter span. Negative and positive moment of longer span. Effective depth of section, and thickness of slab. After getting the negative and positive moments of both shorter and longer span, solve the area of steel required from the moments of the shorter span and its equivalent bar spacing for short direction bars. This time, solve the area of steel required from the moments of the longer span and its equivalent bar spacing for the long direction bars. Next, we test for shear stress of short and long direction by solving their corresponding shear forces and stresses, where the design shear stresses should be less than the shear stress capacity of concrete. Finally, we test for bond stress of short and long direction, where the design bond stresses should be less than the bond stress capacity of concrete. Choose between bent bars and straight bars from our design results, and the common format are as follows. Design criteria. Dimension, longer span by shorter span. Thickness of slab, short direction bars, and long direction bars. Thank you for watching. Please like, share, and subscribe to our channel.